This is the help video for problems 1 through 10. We have here we're going to get y by itself. We're going to add 3x to both sides. So I end up with y equals 3x plus 3. That means y equals mx plus b. Our b is positive 3. And our slope is 3 over 1. We need to be comfortable graphing lines. Positive slope goes up from left to right. Now for number 2. Taking a look here. Main thing you need to watch out for is if you have 2 equal angles, you have 2 equal sides. So 2 equal angles, 2 sides are equal. Chase that down into the corners. That means if this is 37, right here, that's 37. You ask yourself, what else can you find? I see a triangle here. So we learned 37 plus 37. 74 away from an 80. 106, that means this angle right here has to be 106. Should also watch out for linear pairs. When I sweep that, that's 180. 180 minus 106, of course, is 74. Watch again those hatch marks. Hatch marks are here. That means if this is 74, right here, this is 74. I get 148. Take that away from 180. And of course, I get 32. So remember linear pairs, 2 sides equal, 2 angles equal. Number 3 is asking for a translation, reflection, rotation. And here it's obvious that that is a rotation. This, you pretend there's a mirror there and you see it's a flip over a mirror, so that's a reflection. This is another reflection. This one is just a slide, the exact same image, so it is a translation. Problems from 4 are asking you to identify the corresponding parts. So this is saying if the triangles are equal, the whole triangles are equal, then the parts are equal. So it says angle A with triple hatch marks is going to be congruent to angle Z. And angle B with 1 hatch mark is angle X. And angle C, 2 hatch marks over here, angle Y. That seems simple. Now you have to watch your direction here. This is A to B. So A to B, we're going triple to single. So we have to go triple to single again, and that's going to be ZX. Then A to C, that's from triple to double. So triple to double this way, that's going to be ZY. And then here we have B to C, that's single to double. So single to double, that's X to Y. And then we do the last one. You want to watch the sides here. This is angle CAB. So single, start at C, that's double, triple, single is the order. Double, triple, single. That's going to be YZX. You just want to make sure you align the vertices here. Okay, what this is asking you is to identify the shortcuts. So we're going to blow this up so it's easy to see. And here on the left, we see that we have a pair of angles, pair of sides, and then another pair of, and whoop, careful, because on the left, the side is sandwiched between the angles, but on the right, see that? There's your angles. The side is not sandwiched. So watch out for that, because the left spells angle, side, angle. The right spells angle, angle, side. It does not match. So that's a not necessarily congruent. Let's check this out. We have a pair of angles, a reflexive side, and right angles. This one is going to be congruent. And you have to align the vertices very carefully. U, V, W. So that's U, outward, inward, up. So you have to go outward, outward, inward, up again. So your match there is going to be X, V, W. And then you have to match the congruency. That one's angle, side, angle. Take a look here. One hatch mark, side. Double hatch mark, side. Triple hatch mark, side. So this is congruent. Side, angle, side. Now you need to align those vertices. M, N, O. M, N, O. Watch the hatch marks. We went across the double, then the triple. So we have to go across double, then triple. That's going to be R, Q, P. R, Q, P. Now for 6, we're going to complete the proof. So we start with given. Given implies previous talk through. It is given that EF and GF, so EF, GF are congruent. We have a side. And we have DE and DG congruent. We have another pair of sides. We just finished our given. Now implied and freebies. What else do we know is congruent here? Well, we also know that this side DF is congruent to DF because it's reflexive. So it's really easy to see when we do our talk through that we're going to end up with side, side, side. So now we just watch the proof. EF and GF are congruent. We know that because it is given. Then we come over here. DE is congruent to DG, given. DF is congruent to DF. That's called the reflexive property. Now we can say that triangles are congruent by side, 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 but we have to name where we get those sides. We get the sides from step 1, step 2, line 2, and line 3. Let's try another one. We are given here that RS and TU are congruent. Pair of sides. Angle SRT, sweep, is congruent to angle UTR. Sweep, pair of angles. And we're trying to prove these two triangles are congruent. RST is congruent to TUR. But what else do we know is congruent here? We know that this side, RT, is congruent to RT. That's called a side. So our talk through, we know these are congruent by side, angle side. Now we're going to fill in the blanks. RS is congruent to TU, why? It's given. Angle SRT is congruent to angle UTR, and we know that it is given. Then we're doing the reflexive property, which is RT congruent to RT, reflexive property. Finally, the triangles are congruent because of side, angle, side, but you have to name them. This gave us a pair of sides, that's line 1. This gave us a pair of angles, that's line 2. This gave us a pair of sides, that's line 3. Now in 8, we're learning to deal with overlapping triangles. So what we have to do here is step 1 is I highly recommend when you do this, you use 2 different colors, which I'm going to do here. So it's easier to follow. So if you want to really be on top of this, you're going to get 2 different colors right now. So in this diagram, we are told that triangle QRF, trace that in 1 color. This is Q, this is R, this is S, is congruent to TSR. This is T, this is S, this is R. Now we're going to fill stuff out. It says choose the following statements about the 2 triangles. The triangles have a common side. Yes, if you look very carefully, right here, do you see RS? Do you see RS? If you look back at the original, RS is shared. That's called a common side. So we have here, yes, common side is RS. Do they have a common angle? Do they have an angle that's exactly overlapping and shared? Look very carefully at all the angles here. I'm going to sweep them. In this angle, we have 7, 1 and 9 together, and then 3. So we come over here. There's not really anything there in common. Let's check here. 5, 4 and 3 together in 1. And if you look, nothing's in common, so it has no common angle. So the triangles have what angles in common? And they do not have triangles in common. So it's going to be this one. Number 9. Okay, this one you're going to have to do your own proof. That's why given, implied, freebies, talk through is very important here. Given, implied, freebies, talk through. We are given that RT and VT are congruent, so we trace it. Pair of sides. Angle RST is congruent to angle VUT. That gives us a pair of angles. We are done with our given information. Implied and freebies. We have a freebie here. That is this angle in the middle, congruent because of vertical. Now you look very carefully. Why are these 2 triangles congruent? RST. And you're asking why is it congruent to the VUT? And you can see here that the side is a tail of 1. It's a tail, so it's going to be angle, angle, side. So this is the order that we're going to shoot for here. Okay, so we're going to go for our angles first. One set of angles. I'm going to get my given ones. That's the easiest. So we write angle RST is congruent to angle VUT. And why do we know that? It is given. And we're going to go for the vertical angles in the middle. I'm going to call this angle right here RTS is congruent to VTU. There's our other angle. And that is because vertical angles are congruent. Now we have to go for our side. And we were given the fact that RT was congruent to VT, and the reason is it is given. You can see in the margin we have angle side, so now we can say triangle RST and we can see its angle side. It's going to say which line, so line number 1 gave us the angle, line 2 gave us the other angle, and line 3 gave us a side. Let's try one more. Let's careful here. We have overlapping triangles, PQS. So first thing we're going to do here is we're going to separate them. PQS is going to be congruent to RSQ. Let's bring our numbers over. That's angle 2. This right here was angle 3. Okay, let's see what we can do here. We have given, implied, freebies, talk through. Given, implied, freebies, talk through. We are given the fact that PS and RQ are congruent. In the original, it's PS and RQ are congruent. Here, let's get our letters over. We forgot to bring those over, or I did, excuse me. R, S, Q, and then S, Q, P. PS and RQ are congruent. We get a pair of sides. We also know that 2 and 3 are congruent. So 2 and 3 are congruent. Another pair of sides. That's done with our given, implied, and freebies. There is a freebie here. Watch very carefully. You can only see it in the original overlapping triangles. Is that they physically share this side. I know they share it. There's an SQ, SQ, SQ. Oh, it's the exact same thing. So we have a pair of sides. And we talk it through. You see that we have a side, an angle, and a side. So let's document that. We're going to go with side, angle, side. Step 1 is we have side, PS and RQ. Reason we know that it is given. And we had the 2 angles. We know that that is given. And this last side, it's going to look a little strange, but that side SQ is congruent to side SQ, and that's going to be called the reflexive property. Finally, you can say the 2 triangles are congruent. Because of side, angle, side, and you're going to have to name the lines. Line 1 gave you the first side. Line 2 gave you the angle. Line 3 gave you the other side.